A few months ago, I went to an art museum. There was a very special exhibition inside, with only one route. Everyone had to line up, move towards slowly, and watch as they walked. I had to wait in line for about half an hour just to see the first exhibit. So I started wondering if designing the route this way wastes everyone's time, and if there is any way to reduce the wait time. This is a museum simulation software I made. It is a top-down view. The circle are people. They will follow the only routes and move toward continuously. The gray squares are walls, and these yellow and red blocks by the wall are the exhibits. Everyone has their own fixed patience value. Higher patience means they are more patient and will look at each exhibit longer on average. Each exhibit also has its own attractiveness, representing how attractive it is. For more attractive exhibits, people will look at them longer on average. So when a person with high patience meets an exhibit with high attractiveness, they will look at it for a really long time. Blue people means they are waiting for persons in front of them, while green means they are currently looking at the exhibit. The shade of the color represents their patience. Darker means more patient. Each warm color square represents an exhibit. Visitors can only see it when they are adjacent to it. Red means the attractiveness is highest, while yellow is the lowest. We calculate two kinds of time. One is average time spent in the museum, and the other is the wait time. The difference is whether it includes the time spent actually looking at the exhibit and the walking time, which is default 0 if not mentioned. People will continuously enter from the entrance, and the chart on the right records how long each person stays on average. Since people only have one route to move, the moving speed of the whole line usually depends on the person who looks the longest. First, let's look at the normal exhibition hall. You can see people go through a U-turn first before the exhibit starts. This is actually what I encountered at the museum. As you can see clearly, one or two people are really slow, blocking a whole line of people behind them. The reason I want to research this problem in the first place is because the hall I went to had this U-turn, which I feel was pretty useless. So I simulated whether it would actually be faster without this U-turn. To compare the difference, I removed the random factor of patience and compared them under the exact same conditions. You can see that after removing the U-turn, the wait time dropped a lot, leaving only about 1/3 of the original. So I hypothesize, does the average stay time depend on how many waiting spots there are before the section starts? Because of this, I moved all the exhibits in a non-U-turn layout forward, recorded the exhibit starting position and average stay times, and plotted the chart below. You can see a perfect linear relationships between the two. My explanation is that because infinite people are continuously pouring in, which was actually the case that day, those aisles between the exhibits are actually just letting people who should be waiting outside enter first and wait inside. Since waiting outside doesn't count towards the stay time, starting the exhibit right at the entrance naturally results in a lower total watch time. Because people have different patience levels, I previously concentrated the patience distribution on a point to make a comparison, meaning patience standard deviation is 0. As we increase the standard deviation of patience distribution, there will be more people with widely different patience levels. Because of this, the wait time goes up, as shown in the graph below. Since the data size isn't big enough, there's a little fluctuation, but the overall trend of waiting time is increasing. Is it possible to make the whole line move faster by changing the order of exhibits? Let's try two extreme cases, ordering from the most attractive to least attractive, or the other way around. You can pause for a second and think about which one is better. Actually, it is better to put the most attractive ones near the entrance. This can partly explained by the theory from earlier. In a situation with no randomness, if the end is the most exciting part, the bottleneck is at the very back. Everyone looks very slowly there. People behind them finish looking at the exhibit quickly, and the rest of time is no different from looking at the wall to them. Essentially, we're back to the previous problem. The longer the line look at the walls, the longer the total time costs. But if we put the one that takes the longest at the very front, very few people are looking at walls, so there's less meaningless wait time. Because everyone is the same, once they pass the bottleneck, they won't be blocking and go all the way to the end, moving faster and faster. With randomness introduced, putting the best stuff at the end takes even more time for audience. I think it's probably because if the best is at the back, a particularly patient person meeting a particularly exciting exhibit at the end will look for a really long time, blocking everyone. But if the exciting stuff is at the front, only first short section is jammed. The later parts might jam a little bit, but mostly it can move towards smoothly. The below graph shows put attractive exhibits at the front or back, average time scale with the patient's deviation, but not a lot. By calculating the difference between the two time graphs, I made this graph to see if there's a clear trend that put good stuff at the back is affected by deviation more, but even if there is a trend going up, it's not clear. Back then, the U-turn at the museum I went to wasn't actually made of walls. It was actually just fenced off. So if the exhibits are quite large, you can look at them a bit while waiting in line, and then finish looking at them the rest when you get in front of them. So would that reduce the total time spent? To test this, I added a new mechanism. First is the brown fence. Unlike walls, people's line of sight can pass through fence to peek exhibit up to 3 blocks away, reducing the time they need to watch when they actually face the exhibit later. The maximum ratio of watch time reduced by peeking is represented by peak reduction. Obviously, it would be faster compared to a normal mode where you can peek. But if everyone can pick, could intentionally making a U-turn actually be faster than not doing it? The answer of course depends on the value of peaking reduction, so I drew this relationship graph. Turns out the peaking effect is not too bad. As long as peaking lets them see over 36% of the stuff in advance, making a U-turn is a better choice. What if we reduce everyone's movement speed, walking slowly to the next exhibit after watching? The graph below shows the relationships with watch time. Actually, walking slower reduces everyone's wait time but increases everyone's average stay time. Because rather than standing still and waiting important, they are now walking slowly, so they don't feel like they are waiting. But for section they could have passed quickly, walking slowly will naturally increase the total time. Earlier, we were looking at the group level, but from a personal level, it feels like people who watch slower are less likely to feel blocked because they were the ones blocking others. So I did some statistics in graphing the relationships between a person's patience and total wait time. The result is pretty obvious. Patience and wait time have a negative correlation, meaning the slower a person watches, the less likely they are to be blocked. Therefore, when designing a museum route, you need to follow these principles to reduce wasting visitors' time. First, place exhibit right at the entrance. Don't make people line up after entering. Second, put an attractive exhibit at the very front. Even though visitors will see more and more boring exhibits, and might suspect the museum has run out of good ones, which is actually true. Saving time is what we care about here. Lastly, if the exhibits are big and suitable for picking, you might as well add a U-turn. The line of sight can pass through. It might actually let everyone see things faster. That's it for now. Hope you have a nice day.